students. So today we will go to learn a new topic in physics, that is vectors. What are vectors? To know what are vectors, we need to know certain things, that is scalars. What are scalars? Then we will be able to understand vectors. So let us know what are scalars. Scalars are physical quantities that give only the information about magnitude. Physical quantities with magnitude. For example, if we take physical quantities, for example, distance. Second is speed. Okay, so distance is an example of a scalar quantity. Speed is an example of scalar quantity. Okay, like for an example, I'm giving you a sentence, you will understand. Rahul traveled a distance of 30 kilometers. This sentence gives us the information that how much distance have Rahul traveled. That is 30 kilometers. So we only get to know that he have traveled a magnitude distance of 30 kilometers. Okay, but we don't know from where he have traveled, to which direction, or in which side he have traveled. We don't know anything. So distance, speed, all these are scalar quantities. And in respect to scalar quantities, vectors gives us a lot of information. So vectors gives us not only the magnitude, but also the direction. So physical quantities with magnitude and direction. Magnitude and direction. So, example you can take as displacement. Displacement is a physical quantity where we get to know both the magnitude and direction. Okay, and another example, that is, velocity. Okay, velocity. So another example is velocity, where we get to know the magnitude and direction both. For example, if I change this sentence, Rahul traveled a distance of 30 kilometers, by Rahul traveled a distance of 30 kilometers towards the south of the temple. Okay, so if I use this sentence, see, Rahul traveled a distance of 30 kilometers towards south of temple. Here we get to understand that that Rahul have traveled not only 30 kilometers, but another information that it have traveled towards south direction from the temple. Okay, so this thing, 32 kilometers towards south of the temple, both of these things gives us the information that Rahul traveled in which direction and the magnitude, how much it have traveled. So scalars and vectors. Scalars give us only the information about magnitude, and vectors gives both magnitude and direction. Okay, so these are the differences between scalars and vectors. So I hope that you will be able to differentiate easily between scalars and vectors. Okay, So now moving to vectors. What is vectors? We have understood the basic concept of vectors. Now we have to understand vector algebra and how, what are the fundamentals of the vector algebra. To understand the vector algebra, we need to know certain fundamentals. For that, I will just clear. Okay, fine. So let's start. There are fundamentals of vectors. Okay. To know this thing, we need to know certain basic things in vector. First is what is called a position vector. Position vector. Position vector is a vector. We consider the distance or it have traveled from the origin in a coordinate plane. Coordinate plane means XY plane. I will draw and I will make you understand. Okay. Suppose this is the Y plane. This is the XY plane. This is the X-axis, Y-axis I have drawn. And you know in a coordinate, this is the coordinate plane. This is the O means origin, 0, 0. Okay, I hope you know this basic thing. So, a position vector is a vector from which the distance from the origin of that vector. Suppose this is the position vector P. Okay, we will be taking the distance like this. See, I will be drawing it and I hope you will understand. This. See, I hope you can see it. So this OP, the distance from the origin of this position vector P is called the position vector. So this is a vector P and the position of it from the origin in a XY coordinate plane is called the position vector P. How to represent a vector? This is also a very important thing that you need to know. While representing a scalar quantity, we just write A, B, C, anything. We don't need to mention any direction because we only have to mention the magnitude. But to represent a vector, how to represent a vector? We need both magnitude as well as direction. For that, a vector like, see, the vector, let's take this vector A. Okay, and this vector A will obviously have a starting point. Let's take this capital A and an ending point. Let's take this capital B. And it's moving from A to B. We have to specify the direction in a vector. That is the most important part. This is vector A. So it will have a starting point and an ending point. So representing this vector small a will be like this. See? Like this, have traveled direction like this. That is. This is the representation of a vector. Not only A, you can take any other B, C, D, E, F, R, J, K, anything, X, Y, Z. But this is the basic representation of a vector. It always have a head and a tail. Okay, so starting point, ending point. In the ending point, in which direction it is moving, you have to specify the arrow in that direction. If it have moved from this B to A, we would have marked the arrow here in the A position. But in this case, it have moved from point A to B, so we mark the arrow like this, specifying the direction of the arrow in which it is moving. Okay, so you get to know what is a position vector. The position from the origin of a coordinate plane, that is the XY plane, is the position vector. And how to represent a vector. You get to know these two fundamental things. Now we will be knowing more about vectors. To know the fundamentals of vectors, we have known the how to represent vector, position of a vector. The second thing that we need to know is okay. So the second thing we need to know is displacement vector. What is a displacement vector? Similarly, like the previous one, we will be drawing a coordinate plane to understand what is a displacement vector. This is the y-axis, and we will be drawing a x-axis for the coordinate plane, and we will be taking a position vector p. Okay. Towards the origin of the coordinate plane. Suppose this. Okay. So, see, this is the y-axis. This is the x-axis. This is the origin O, that is 0, 0. Suppose this is O and this is the position vector P here. Okay. So now, suppose the position vector P have moved from a position P to a position Q, like this. This position is called Q, this one. This position is Q, okay. So this position is Q. So this vector OP have moved from the position P to Q. So what is the displacement between this position P and Q? That is PQ. So this vector PQ is called the displacement vector. Okay. So this vector PQ is called the displacement vector. That is from P to Q it have moved. So here it is called displacement vector. So any vector which have moved from a position to another position, the vector between the positions is called the displacement vector. Simple as that. Not a big deal. Don't be scared. Try to understand, and it is very easy, just like water. Okay, these are very basic concepts, and if you feel any problem, you can ask me. So PQ is the displacement vector where the vector have moved from a position P to a Q. So we have learned about position vector, how to represent a vector, and displacement vector. The third thing I will be teaching you is the equal vectors. What are called equal vectors? Vectors which have both same magnitude and direction. Suppose we are taking a vector A. Representation will be like this, and a vector B. Okay, I will be drawing the vectors. Watch it carefully. So this is the vector A, and similarly, this is the vector B. Okay. So both of them, if they have the same direction and the same magnitude, Like I am supposing it is 20 meter. And this is also 20 meter and both are in the direction west. So both have same direction as well as the same magnitude, A and B. So A and B are equal vectors. They are called equal vectors if they have both same magnitude and same direction. But in contrast, if, let me draw the negative vector, it will help you to understand. Yes. So the fourth one is negative vector or negative of a vector. Vectors which have same magnitude. Same magnitude, but opposite or different direction. Opposite direction, to be more specified, are called negative of a vector. I'm giving you an example. Let's take this only, A and B. Okay, if I draw it, you understand. Okay, so see why I have drawn this A from this point to this point, but B from this point to this point. So they see the direction, the arrowhead. See, the arrowhead are in opposite direction. It is A starting from this point and ending at this, going in this direction. Like I have taken this direction as west. And so obviously the opposite direction will be east. So from starting from this point and going in this direction. But let it take that they both are of same magnitude, that is 20 meter. 20 meters, same magnitude, but different direction, west and east, opposite direction. So it is called a negative of a vector. I hope you understand this. So let's go to the next thing. That is the fourth thing is called unit vector. It is a very important and a very interesting concept. What are unit vectors? Unit vectors are those vectors which have magnitude unity but specify a unique or specified direction are called unit vectors. So vectors which have magnitude unity means obviously you know 1, which have magnitude unity and specifies unique direction. Okay. Now we have known what is the concept of unit vector, but we need to know the mathematical formula or the mathematical concept. Unit vectors, like the other vectors, we have seen that the vectors are represented like this. See, taking the example of A vector, capital A, they are represented like this. They have a head and a tail. But unit vectors are represented like this. A cap. Okay, unit vectors are represented like this. for understanding the mathematical concept of unit vectors, apart from knowing the vector and the unit vector representation, we also need to know modulus of a vector. Modulus of a vector. What is the modulus of a vector? That is magnitude of a vector. That is only the number or the magnitude of the vector. Suppose the vector symbol is A vector. What will be the modulus or the magnitude of the vector? It will be like this. See, mod A vector. This is the magnitude or the modulus of vector. Okay, modulus of this A vector. Okay, so we have known what is the modulus of a vector. That is the magnitude or just the number which gives only the magnitude of the vector. To understand the unit vector, we need this vector, unit vector, and this. So the mathematical concept of unit vector. Mathematical concept of unit vector. Unit vector A cap is equals to A vector by modulus of A vector. Okay, unit A vector gives A vector divided by the modulus of A vector. Modulus meaning the number, only the magnitude. A vector is the whole vector which gives both magnitude and direction, and unit vector only specifies in which direction the A vector is moving. So unit vectors give only the direction. It specifies the direction in which the vector lies. I hope you have understood this. Okay, understood this. And it have always a magnitude, that is unity. It is very important to understand that unit vector always have a magnitude, unity, and it specifies the direction in which the vector lies. And what is the mathematical concept of a unit vector? This is the symbol of unit vector. So these are the fundamentals of a vector algebra.